It didn't arrive with a warning. No flash, no explosion, just a quiet mark on a screen, moving against the dark. Out beyond the ecliptic, where most objects never come from, something was drifting in. Slow, clean, silent. Astronomers gave it a name, the way they always do. 3I/Atlas. Another visitor from another star, they said. Rare, but not impossible. At first, no one felt fear. No one felt wonder either. Because discoveries like this are supposed to feel routine. A faint dot, sliding through the cold, a path traced by math, a future already written by gravity. This was supposed to be simple. For months, automated surveys scanned the sky every night. Thousands of moving objects were flagged, measured, sorted, and forgotten. Most were rocks, some were ice. All of them followed the rules. Then, one night, 3I/Atlas appeared. It came in fast, but not reckless. Its path cut across the solar system at an angle that didn't match our planet's. That alone told scientists something important. This object wasn't born here. It came from interstellar space, from the deep dark between stars. Only 2 objects like that had ever been seen before. Both were strange, both were brief. So when 3I/Atlas was logged, the reaction was calm, professional, almost bored. Another data point, another paper, another footnote in the long history of the sky. Telescopes turned, instruments adjusted, light was collected, split, and measured. And at first, everything looked normal. Its brightness rose slowly. Its motion followed gravity. Its size fell within expected limits. A cold object, old, worn by time. Exactly what a wandering rock should be. But then, the numbers kept coming, and the calm began to crack. The first sign wasn't dramatic. It was small. Almost invisible unless you knew where to look. The light curve didn't settle. As the object rotated, its brightness should have risen and fallen in a smooth rhythm. Spin, reflect, fade, again and again. But 3I/Atlas didn't do that. Its light jumped, paused, then dipped too fast. At first, scientists blamed the data. Bad pixels, cosmic noise, a calibration error. They corrected it. The curve stayed wrong. They waited another night. Still wrong. Another telescope confirmed it, then another. Different instruments, different countries, same strange shape in the data. The light curve wasn't just uneven. It was inconsistent, as if the object couldn't decide how bright it wanted to be. As if something about its surface was changing. That shouldn't happen. Rocks don't choose how they shine. A natural body spins the same way every time. Ice sublimates. Dust spreads. Physics repeats itself. But 3I/Atlas didn't repeat. It hesitated. It was subtle. So subtle that no one spoke out loud about it. Not yet. Because science is careful. It doesn't jump to stories. It double-checks. It doubts itself first. Days passed. The object moved closer. More data poured in, and the quiet discomfort grew. Spectral analysis showed nothing familiar. No clear dust coma, no long gas tail. Just a clean point of light holding itself together. That was odd, but not impossible. Then came the reflectivity readings. The surface seemed to brighten and darken in patches. Not smoothly, not randomly, in sections. As if parts of it were turning while others stayed still. That made no sense. A spinning rock doesn't have parts that choose when to shine, unless the surface isn't uniform, unless it isn't passive. Still, no one used that word, not yet, because the discovery phase is a fragile thing. You don't want to be the first person to say something foolish, or worse, something unbelievable. So the language stayed careful, unusual, unresolved, worth further observation. But behind the words, a feeling had begun to form, a feeling scientists rarely admit. Confusion. 3I/Atlas was now officially classified as interstellar, the third object of its kind ever seen. That alone should have been the headline. But inside research circles, something else mattered more. This visitor wasn't behaving like the others. It wasn't tumbling wildly. It wasn't shedding material. It wasn't breaking apart under solar stress. It was stable. Too stable. As it crossed invisible lines of radiation and heat, its brightness didn't react the way models predicted. It adjusted, slightly, quietly, as if it knew the sun was there long before it felt the heat. Again, no one said that out loud. But the thought lingered. Observation continued. Each night, the object crept closer, pixel by pixel, and with every update, the gap between expectation and reality widened. The sky was still calm. No alarms, no announcements. The public had no idea this was happening. To them, the universe was the same as yesterday. But in a few quiet rooms, lit by screens and coffee cups, something had shifted. Because discoveries are supposed to answer questions, this one was asking them. What kind of object travels between stars? Enters a foreign system and refuses to act surprised? What kind of rock doesn't tumble when disturbed, doesn't shed when warmed, doesn't flash the same way twice? The data wasn't screaming. It was whispering. And whispers are harder to ignore. By the time 3I/Atlas was weeks into observation, one truth had settled in. This was not a mistake. The instruments were working. The math was solid. The sky was being honest, which meant the problem wasn't the data. It was the assumption that everything we find out there must be natural, that every visitor must be dead matter, drifting without purpose, that the universe only speaks in chaos. 3I/Atlas didn't fit that story, not yet. But it had already done something rare. It had made certainty uncomfortable. And in science, that's where real discoveries begin. The object continued its silent approach, still faint, still distant, but no longer ordinary, because once you notice something doesn't behave like it should, you can't unsee it. And the sky, for the first time in a long while, was holding its breath. So the question remained, hanging between stars and screens. If this wasn't just another rock, what did we invite into our sky? At first the change was so small, it almost slipped by. A slight rise in brightness, a pause that shouldn't exist. A fall that came too late. On a graph, it looked harmless. Just a soft bend in a thin white line. But to the people watching, that line was lying. Because a light curve is supposed to be honest. It's one of the oldest tools in astronomy. Simple, reliable. You watch how an object brightens and dims as it spins, and the story reveals itself. Spin fast, the curve tightens. Spin slow, the curve stretches. Irregular shape, uneven light. Every rock tells the truth this way. Except this one. As tracking sharpened, telescopes across the world locked onto 3IATLAS with precision. Larger mirrors, longer exposure, cleaner data. No guessing now, and that's when the curve began to bend in ways no one expected. Instead of dimming as it turned away from the sun, it brightened. Instead of peaking once per rotation, it peaked twice. Then, sometimes, not at all. The curve twisted back on itself, like it couldn't decide what it wanted to be. Scientists stared at the screen longer than they meant to. Not alarmed, just unsettled, because this wasn't noise. Noise is messy, random, ugly. This was smooth, intentional looking. The brightness climbed gently, held steady, then dropped sharply. Not the messy wobble of a tumbling rock. More like a controlled movement. Someone suggested it might be elongated, a long, thin shape reflecting more light at certain angles. That idea had worked before, so they tested it. The model failed. No rotation speed could explain the timing. No shape fit the pattern. The light was changing, without the object turning. That's when the word reflectivity entered the conversation. Reflectivity is simple. Some surfaces shine more than others. Ice reflects. Rock absorbs. But reflectivity shouldn't change on its own. A surface doesn't decide to become brighter unless something is happening on that surface. The data suggested patches, zones, areas that brightened and dimmed independently, as if different sections were responding at different times. But responding to what? There was no dust cloud forming, no gas release detected, no visible plume. Comets announce themselves. They flare, they shed. 3I/Atlas stayed clean, almost polished. Night after night, the curve repeated its strange behavior. Not perfectly, but close enough to feel deliberate. The rises happened around the same intervals. The dips followed familiar spacing, too ordered for chaos, too precise for chance. One researcher quietly reran the analysis, assuming instrument error. Different filters, different calibration. Same result. Another checked whether background stars could be interfering. They weren't. The sky behind it was empty. The object stood alone, doing this by itself. As confidence in the data grew, certainty began to erode, because certainty depends on rules, and the rules were breaking down. The light curve no longer described a spinning body. It described behavior, a sequence, a change that wasn't tied to motion, but to timing. And that made no sense. In nature, timing comes from movement, from rotation, from orbit. This timing seemed internal. That thought was never written down. Not officially, but it was there, unspoken, lingering in the silence after meetings ended. Because if the light wasn't tied to rotation, then what was it tied to? The sun? No, the peaks didn't line up with distance. Heat? No, the thermal data didn't match. Impact? There was nothing to collide with. That left only one uncomfortable idea. The object's surface properties were changing on their own, as if parts of it were turning toward the sun, without the whole body turning, as if it had sides, but didn't need to spin to show them. That's when a senior astronomer leaned back in his chair and said something soft. Are we sure we're looking at the whole thing? Because maybe that was the problem. Maybe the light curve wasn't lying. Maybe it was telling a truth no one wanted to hear. What if the object wasn't a simple shape at all? What if it had layers, or structures, or surfaces that moved independently? What if the shape we assumed was wrong? The models were updated again. More complexity, more variables. Still no fit. The curve refused to behave. And the more they tried to force it into something familiar, the stranger it became. A junior analyst pointed out something subtle. The brightness changes weren't just uneven. They were selective. Only certain wavelengths shifted at certain times, as if some materials were being exposed, while others stayed hidden. That suggested control, not random erosion, not natural cracking, control. The room went quiet after that. No one said the word artificial, but everyone heard it, because rocks don't hide surfaces. They don't reveal themselves in stages. They don't manage how light touches them, unless they were built to. The idea felt absurd, dangerous, so it was pushed away. Yet the curve remained. Night after night, 3I/Atlas continued its approach, calmly bending the rules of brightness. Not enough to cause panic, just enough to cause doubt. And doubt is powerful, because doubt spreads quietly. It makes people recheck assumptions they've trusted for decades. It makes them ask questions that feel wrong to ask, like, what if we're not seeing a natural object at all? What if this visitor isn't tumbling through space, but presenting itself, showing one surface, then another, on its own terms? The light curve didn't scream a message. It whispered a question, and the question hung there, unanswered. Is the object hiding its true shape? Or worse, is it showing us exactly what it wants us to see? As the nights passed and the curve continued to lie, one thing became clear. Whatever 3I/Atlas was, it wasn't just reflecting light. It was shaping perception. And once perception shifts, there's no going back. It started as a flicker, so small, so easy to dismiss, just a tiny rise in brightness, then a fall, a heartbeat that could have been noise. At first, that's what everyone called it, noise, because space is loud in its own way. Cosmic rays hit sensors, electronics drift, stars shimmer in the background. Every astronomer learns this early. Not every signal means something. So when one telescope noticed a brief pulse in 3I/Atlas's light, it barely earned a note. A spike, a dip, gone. But then it happened again. Same telescope, same timing, still nothing alarming. Until a second observatory, thousands of kilometers away, logged the same thing. Same rise, same fall, same spacing. That's when the room grew quiet. Because coincidence has limits, and this was starting to push them. Across continents, data streams flowed in. Chile, Hawaii, Europe, Australia, different skies, different instruments, different nights. Yet the pulse kept appearing. Not always strong, not always clean, but always there. At first, it felt messy, uneven, easy to ignore. But as more hours were stacked, more nights layered together, something clicked. The noise began to line up. The flickers weren't random. They were rhythmic. A rise in brightness, a pause, a fall, again and again, like something tapping gently against the dark. Scientists overlaid the data, different observatories, different time zones. The pulses matched down to the second. That shouldn't be possible. Atmospheric interference is local. Instrument drift is personal. Timing errors don't travel across oceans, but this did. The pulse wasn't happening to the telescopes. It was happening out there, at the object. Someone slowed the playback, then slowed it again. The rhythm became obvious. Not perfect, but close. Too close to ignore. The brightness rose in clean steps. Not smooth, like rotation. Not chaotic, like debris. Step, pause, step. Almost like counting. The first instinct was rotation. Everything rotates. But rotation leaves fingerprints. A predictable cycle. A shape-driven curve. This wasn't that. The pulse didn't care how fast the object was spinning. It didn't align with its assumed axis. It arrived on its own schedule. Then someone asked the question no one wanted to ask. Is it synced? They checked, and the answer was worse. The pulse timing didn't drift. As the object moved closer, as distance changed, as viewing angles shifted, the rhythm stayed steady. That meant it wasn't an illusion of perspective. It wasn't a trick of light. It was intrinsic. Something about 3IATLAS was turning on, then turning off, over and over. The room felt colder after that, because nature rarely repeats itself this cleanly. Stars pulse, but they swell and shrink. Pulsars spin, but they scream in radio waves. This was different. This was quiet. A soft optical signal, barely brighter than background noise, almost polite, like it didn't want attention, but didn't mind being noticed. They checked other wavelengths. Infrared showed a faint echo of the same rhythm, not strong, but present. Ultraviolet showed nothing. Radio, silence. Whatever was causing the pulse, it wasn't broadcasting loudly. It was whispering. One analyst joked nervously that it looked like a heartbeat. No one laughed, because heartbeats imply life. And that was a line no one was ready to cross. So they called it an oscillation. A safe word, a technical word. Something that doesn't scare funding committees. But words don't change patterns. And the pattern kept tightening. As more data arrived, the pulse sharpened. The rise time stayed consistent. The fall time stayed consistent. The spacing between peaks barely changed. Not even when solar radiation increased. Not even when background noise rose. The signal held. Someone plotted the pulse timing against known physical processes. Thermal expansion, outgassing cycles, magnetic interactions. None matched. The pulse didn't care about temperature. It didn't care about sunlight. It didn't care about chaos. It kept its own time. That's when a quiet realization spread through the group. Timekeeping requires reference. Something has to count. Something has to decide when now becomes then. Rocks don't do that. Ice doesn't do that. Dead matter reacts. It doesn't schedule. A senior researcher finally said what everyone was thinking. This looks like a signal. The word landed heavy, because signals imply intent. They imply sender and receiver. Even if the sender doesn't know who's listening, the team tried to prove themselves wrong. They scrambled the data order. The pattern survived. They removed sections. The rhythm reappeared. They added artificial noise. The pulse pushed through. It was resilient, like it wanted to be seen, but not understood too quickly. And the strangest part? The object wasn't pointing at Earth. The pulse didn't align with us, which meant, if this was a signal, it wasn't meant for us. We were just in the way. That thought sat heavy. because it meant the universe might be full of conversations. And we're only catching fragments by accident. As nights passed, the pulse remained calm, unbothered by our attention, unchanged by our confusion. It didn't speed up, didn't slow down, didn't respond. It simply continued. Tick, pause. Tick, tick, like a metronome drifting through space. At some point, someone noticed the human reaction had changed. At first, there was excitement, then curiosity. Now, restraint. People chose words carefully. Meetings ended earlier because no one wanted to be the person who said too much. Because history remembers those moments. The moment when noise becomes pattern, when pattern becomes signal, when signal demands meaning, and meaning changes everything. The pulse crossed the sky night after night, witnessed by eyes that had spent lifetimes studying stars. And yet, this didn't feel stellar. It felt deliberate, not loud enough to announce itself, not hidden enough to be missed, just steady, patient, keeping time. So the question lingered, unanswered, echoing softly in every dataset. If this is a pulse, if this is a signal, then who or what is counting the seconds out there? And more importantly, why now? It should have been the hottest moment. That's what the equations said. That's what experience promised. As 3I/Atlas moved closer to the sun, as it slipped deeper into the inner system, every model agreed on one thing. It should heat up. Solar radiation increases. Surface temperature rises. Ice cracks. Gas escapes. That's the rule. That's how space works. So when thermal instruments began tracking the object more closely, no one expected surprises, just confirmation. But the first readings didn't confirm anything. They confused it. The temperature climbed, then stopped. Not slowed, not leveled, stopped, as if it hit an invisible ceiling. Scientists checked the distance again, checked the sun's output, checked their instruments. Everything was correct, so they waited. As hours passed, the object moved closer, closer still, and then the temperature dropped. Not gradually, not smoothly. It stepped down, clean, sharp, measured, like someone turning a dial. That wasn't just strange. That was wrong, because heat doesn't behave like that in space. A rock absorbs sunlight and warms up. It doesn't pause. It doesn't hesitate. It definitely doesn't cool while approaching perihelion. Yet that's exactly what the data showed. As 3I/Atlas reached a distance where it should have been shedding material, where its surface should have been glowing hotter than ever, it cooled. The numbers were clear. Infrared readings dropped in clear intervals, then stabilized, then dropped again. Step, pause, step. Just like the light pulse. Someone whispered it first. Is this connected? No one answered, because they already knew. The thermal pattern wasn't random. It matched the timing of the brightness changes. When the light rose, heat followed. When the light fell, heat dropped faster than physics allowed. That meant energy was being managed, not lost, not scattered, managed. At first, researchers reached for familiar explanations. Outgassing could cool a surface. Expanding gas carries heat away. But there was no plume, no dust, no tail. The object remained clean, too clean, Others suggested unusual materials, exotic ice, reflective coatings. But even those had limits. No known substance could shed heat this efficiently, this quickly, without leaving evidence behind. And the closer it came to the sun, the more obvious the problem became. Near perihelion, solar energy poured in. Models predicted rising thermal stress, cracking, fragmentation. Instead, the object cooled again, as if it were protecting itself. That idea made the room uneasy, because protection implies awareness, not consciousness, not thought, but response, reaction beyond instinct. This wasn't passive matter being cooked by a star. This was something behaving like a system. Sensors recorded the temperature changes in clean blocks. No jitter, no chaos. Just steps, as if thresholds were being crossed, as if something decided, this is enough. One engineer compared the curve to a thermostat. The word slipped out before he could stop it. No one laughed, because the comparison fit too well. A thermostat doesn't eliminate heat. It regulates it. It allows some, blocks the rest. It maintains balance. That's what the data showed, balance. Someone reran the model assuming a hollow structure. Heat dispersal would be different. It still didn't fit. Another tried layered materials. Still wrong. Another tried rotation effects. No match. The object wasn't cooling because of motion. It was cooling because something was changing how it interacted with sunlight. Reflectivity increased right as temperature dropped, as if surfaces were shifting, reorienting, or activating. That tied back to the light curve. Everything was starting to line up. The brightness pulses, the reflectivity changes, the thermal steps. They weren't separate mysteries. They were parts of the same behavior, and behavior is not something we usually assign to rocks. The room felt different now. Less excitement, more caution. Because once you start talking about regulation, you're no longer describing geology. You're describing engineering. Someone asked the quiet question, what if it's insulating itself? Silence followed, because insulation in space isn't trivial. It requires structure, design, intent. You don't accidentally build something that knows when to block heat. And yet, the object continued to do exactly that. As solar intensity increased, the surface temperature refused to follow. Instead, it oscillated around a narrow range. Never too hot, never too cold, comfortable, stable, almost preserved. That raised another disturbing thought. Preservation implies purpose. Why maintain thermal stability? To protect materials? Electronics? Information? No one said those words aloud, but they hovered in the air. The team began comparing 3I/Atlas to known spacecraft behavior, carefully, quietly. Space probes regulate heat constantly. They open panels, close shutters, redirect energy. The patterns weren't identical, but they rhymed, and that was enough to make people nervous, because this wasn't a probe we launched. This came from outside, from far beyond our sun's influence, from a place with no reason to care about our models, yet somehow aware of the same thermal dangers. One scientist pointed out something even stranger. The cooling wasn't reactive. It was anticipatory. The temperature dropped before the solar flux peaked, before the heat arrived, as if the object knew what was coming, as if it had already passed a star before, or many. That idea cracked something open, because interstellar space is unforgiving. Only certain structures survive long journeys between stars. Most rocks don't. They fracture, they erode, they decay. This object arrived intact, stable, prepared. As the data piled up, one conclusion became impossible to ignore. This wasn't just heat without fire. This was heat without helplessness. 3I/Atlas wasn't suffering the sun, it was managing it. And that meant, whatever this object was, it wasn't just passing through. It was built to endure, built to regulate, built to survive environments it didn't belong to. And that changes how you see it, because natural objects don't plan for survival. They either make it or they don't. But this one adjusted. Quietly, calmly. Like it had done this before. As perihelion passed and the object continued on its path, the temperature stabilized once more. Not burned, not broken, just unchanged. The sun had thrown everything it had, and 3I/Atlas barely noticed. That was the moment when a line was crossed. Not publicly, not officially, but internally. The question was no longer, what is this object made of? It became something far more unsettling. Why does it behave like it wants to stay intact? Because regulation is not an accident. It's a choice. And choices imply something behind them. As the sun faded behind it and the data streams continued, one final thought settled in. If this object can manage heat, if it can regulate energy, if it can protect itself from a star, then maybe the real mystery isn't how it survives the universe. Maybe it's why it came here at all. At first, they thought it was glare, a trick of angle, a trick of distance, a trick of tired eyes, staring too long at the same object. Because brightness can lie. Light bends, instruments drift. That's normal. But this wasn't. As 3I/Atlas continued its journey past the sun, scientists began mapping its surface more carefully. Not just how bright it was, but how that brightness was distributed, where the light came from, and where it didn't. And that's when something unsettling appeared. Whole sections of the object brightened at once, not gradually, not smoothly, suddenly, as if a switch had been flipped. One moment, a region absorbed sunlight. The next, it reflected it cleanly, sharp, controlled, precise. That shouldn't happen. Natural bodies don't change reflectivity like that. A comet brightens because ice turns to gas. Dust spreads. Light scatters everywhere. It's messy, chaotic, beautiful in its own wild way. But 3I/Atlas didn't bloom. It didn't flare. It didn't shed anything at all. No dust plume, no glowing tail, no expanding cloud of debris. The sky around it stayed empty, just a hard point of light, changing how it reflected the sun. That's when someone said it quietly. It's acting like a surface, not a coma, not a cloud, a surface. That word mattered, because surfaces belong to solid things, defined things, objects with boundaries. Comets are fuzzy, they blur at the edges. 3I/Atlas stayed sharp. Even as reflectivity changed, its outline held steady. No haze. No smear. Almost like light was bouncing off something smooth, or flat, or arranged. The reflectivity shift didn't follow rotation either. If the object was spinning, bright regions would sweep across predictably. But these changes didn't sweep. They appeared. One side brightened, while another stayed dark. Then later, a different region responded, as if different parts were taking turns facing the sun, as if they could choose when to engage. That idea made people uncomfortable, because choice implies control, and control implies design. Someone pulled up high-resolution scans from multiple nights. They overlaid them. The bright regions didn't line up with cracks, or fractures, or irregular shapes. They lined up with zones, clean zones, defined areas that behaved the same way every time. That's not erosion, that's structure. They checked polarization data. Light bouncing off dust behaves differently than light bouncing off solid surfaces. The readings were clear. This wasn't dust. This wasn't gas. It was reflection. Direct, intentional looking. The object wasn't glowing. It was redirecting light, like a mirror that decides when to shine. One scientist leaned closer to the screen and frowned. These look like panels. The room went quiet. Panels. A word no one wanted to hear. Because panels are built. They don't form naturally in deep space. You don't accidentally end up with flat, reflective sections that respond independently to sunlight. Nature prefers chaos. This was organized. They tried to argue it away. Maybe layered ice. Maybe metallic minerals. Maybe extreme erosion shaped by time. But every explanation fell apart under detail. Layered ice would sublimate. Metallic minerals would oxidize. Erosion would be uneven. None of that matched the data. The reflectivity changes were too clean, too fast, too reversible. When a section brightened, it stayed bright for a while, then dimmed. Not because it broke apart, not because it rotated away, but because it stopped reflecting, as if it turned itself off. That behavior lined up perfectly with the thermal regulation. When reflectivity increased, temperature dropped. When reflectivity decreased, temperature rose. The object wasn't just reacting to the sun. It was managing its relationship with it. Like a system balancing energy. That's when the comparison became unavoidable. Spacecraft use reflective panels to control heat. They angle them, rotate them, expose them when needed. Not to communicate, not to shine, but to survive. And that's exactly what this looked like. Survival. The sun is violent up close. Radiation strips molecules. Heat tears structures apart. Anything crossing perihelion without protection should show damage. 3IATLAS showed none. Instead, it adapted. The reflectivity shifts happened right before the most intense heating, not after. That meant anticipation, preparation. This wasn't a passive object being punished by a star. This was something that knew how stars behave. That knowledge doesn't come easily. It takes experience or design. As the days passed, the object continued to present different faces to the sun, not rotating randomly, not tumbling, presenting. Each shift, clean, measured, efficient, almost polite. And still no debris, no dust cloud trailing behind, no evidence of stress. Which raised the strangest question yet. If this were a comet, where was the mess? Comets announce themselves. They scream their presence across the sky. They leave trails you can see with the naked eye. 3I/Atlas remained quiet, contained. It moved like a machine pretending to be a rock. Or maybe not pretending at all. Maybe we were the ones pretending. Pretending this was just another natural visitor. Pretending the universe doesn't build things. The reflectivity data forced a shift in thinking. Not public, not official, but personal. Researchers stopped asking, "What material is this?" They started asking, "What function does this serve?" That's a dangerous transition, because function implies intention, and intention opens doors we don't know how to close. One analyst noticed something subtle, but chilling. The reflective zones never faced Earth directly. They angled toward the sun, always, as if Earth wasn't the audience, as if the behavior had nothing to do with being seen. This wasn't signaling. This was maintenance. The object didn't care if we watched. It would have done this whether we were here or not. And that made it feel older than us. Older than our curiosity. Older than our fear. It had rules of its own. As 3I/Atlas drifted farther from the sun, the reflectivity shifts slowed. Less need. Less stress. But they didn't stop. They faded. Gracefully. Like a system powering down. That was the final blow to the natural object argument. Natural processes don't power down. They exhaust themselves. They fail. This didn't fail. It adjusted. And adjustment is the mark of design. As the data was compiled and stored, one final realization settled in. We weren't watching a cloud of dust reacting to heat. We were watching a surface doing its job, a surface that knew where to face, when to shine, when to protect what lay beneath. And that begged a question no one could answer. If this object has a surface, what's under it? And why has it gone to such lengths to keep that hidden? There's a moment in every investigation when the room goes quiet. Not because someone spoke, but because everyone stopped pretending. Up until now, every explanation had stayed safely inside one rule: natural. No matter how strange the data looked, no matter how badly the models bent, the assumptions stayed untouched. This is a natural object, because once you let go of that, you don't just change a theory. You change everything. So most teams didn't go there. They adjusted variables, tweaked materials, blamed unknown physics, anything but the unthinkable, anything but the question sitting silently in the corner. What if this isn't natural at all? It wasn't discussed in meetings. It wasn't written in reports. But a small group noticed something important. Every time they forced the object to behave like a rock, the equations broke. But when they treated it like a system, things started to align. This wasn't a large team. No official task force. Just a handful of researchers. Curious enough to risk embarrassment, they didn't announce what they were doing. They didn't need permission. They just re-ran the simulations. One change. One forbidden assumption. Artificial origin. Not alien life. Not intelligence. Just design. Something built. They told themselves it was only a test. A way to eliminate possibilities. But deep down, they already knew what they were hoping to see. The first model focused on thermal regulation. Instead of exotic materials, they used known engineering principles. Reflective surfaces, insulating layers, directional heat management. The results snapped into place. The temperature steps matched perfectly. The cooling near perihelion made sense, not as a mystery, but as a feature. They moved on to the light curve. Instead of rotation-based brightness, they modeled controlled reflectivity. Sections that activate, sections that dim. The curve straightened. The lies disappeared. The pulse timing, internal oscillation. A simple cycle, not a message. Not a broadcast, just a system keeping itself stable, like a heartbeat that exists only to keep the body alive. They stared at the screen because for the first time since discovery, nothing broke. No contradictions. No impossible jumps. Just behavior. Behaving. One of them leaned back and said softly, "Well, that fits." No one smiled, because fitting is terrifying. When physics fails, you get curious. When design succeeds, you get afraid. They pushed further. What kind of structure could survive interstellar space? Radiation. Micrometeorites. Time measured in millions of years. The model suggested something old, very old. Built for endurance, not speed. Not a probe racing between stars. More like a drifting archive. Or a sensor. Or a relic. Something sent long ago, with no expectation of arrival. That thought hit hard, because it meant this object wasn't responding to us. It wasn't reacting to Earth. It wasn't changing because we noticed it. Everything it was doing for itself. The simulations showed no signs of communication behavior, no targeting, no amplification, just regulation, preservation, as if its only goal was to remain intact, no matter where it went. That made it worse, because it stripped away comfort stories. This wasn't an alien greeting. It wasn't a warning. It wasn't even curiosity. It was indifference. The object didn't care who saw it. It cared about surviving stars. Someone asked the obvious question, if it's artificial, who built it? No one answered, because that question opens doors you can't close. Civilizations rise and fall. Stars live and die. Anything capable of sending something between stars and letting it drift for ages is operating on a scale we don't understand. The team tried to poke holes in their own work. They changed assumptions, added noise, removed constraints. The model still held. Not perfectly, but better than anything else. Better than rocks. Better than ice. Better than chance. They didn't publish it. They couldn't. There was no safe language for this. You can't submit a paper that says design explains this better than physics. That's how careers end. So the results stayed private. Shared quietly, carefully, passed from screen to screen, with raised eyebrows and long pauses. One researcher pointed out something chilling. The design didn't need intelligence on board. No thinking, no adapting, just rules set long ago. If heat exceeds this, reflect more. If temperature drops, conserve. Simple logic, ancient logic. That meant whoever built it didn't need to know where it would end up, just that it would. Eventually, maybe this wasn't sent to us. Maybe it wasn't sent at all. Maybe it was released and left to wander. A message without a destination. Or worse, a test. That idea wasn't popular, but it lingered, because tests don't need witnesses, they need environments. Stars, radiation, time, the universe itself. As the small team compared notes, one realization became unavoidable. This object had crossed distances so vast that even our sun was just another checkpoint. And it arrived intact. That alone is extraordinary. But it also arrived prepared. Prepared for heat. Prepared for cold. Prepared for silence. That's not luck. That's foresight. Someone finally said it out loud. If this is artificial, it's not new. No one argued. The design felt dated, not crude, not advanced, just efficient, like something built by a civilization that learned patience. A civilization that didn't rush, that didn't need answers quickly, that could afford to wait for stars to move. That thought pressed down hard. Because humanity is young, we build things to last years, maybe decades. This thing was built to last epochs, and it drifted into our system without slowing down, without changing course, without acknowledging us, which meant we weren't special, we were incidental. The team shut down the simulations and sat in silence. They didn't celebrate, they didn't panic, they just understood something had shifted. Because from that moment on, every natural explanation would feel forced, and every artificial one would feel uncomfortably clean. They didn't know what 3I/Atlas was, not really. But they knew what it wasn't. It wasn't a mistake. It wasn't debris. It wasn't just another rock. And that meant the question had changed. It was no longer, how do we explain this with physics? It became something far more dangerous. If design explains this better than nature, what does that say about the universe we thought we understood? And more quietly, what does it say about us? Because if something out there can build machines that cross stars and leave them drifting for ages, then maybe the universe isn't empty. Maybe it's patient. And maybe we're only just beginning to notice. It didn't come from an announcement. There was no press conference, no headline, no warning to the world. It leaked. A screenshot here, a clipped sentence there, a quiet post that shouldn't have been public. At first, no one noticed, but the internet always notices, eventually. A strange light curve, odd thermal data, a phrase taken out of context, doesn't match natural models. That was enough. Within hours, the story escaped the labs. And once it did, there was no putting it back. Social media lit up like dry grass. Some people felt awe. This is it, they said. Proof we're not alone. Others felt fear. This is being hidden, they said. Why aren't they telling us everything? And many felt denial. It's fake. It's a glitch. It's just another rock. The same data. 3 different realities. Because when humans face the unknown, we don't react as one species. We fracture. Videos appeared overnight. Threads grew longer by the minute. Experts argued with strangers who suddenly knew everything. The word artificial floated through the noise. Carefully at first, then loudly, too loudly. Institutions responded the only way they know how, with calm language, careful wording, measured statements. No evidence of non-natural origin. Further study required. Premature conclusions. To some, that sounded responsible. To others, it sounded like a lie. Trust cracked. Not all at once, just enough to let doubt through. And doubt spreads faster than truth. People searched the sky for meaning. Some felt small, some felt chosen, some felt angry. Because discovery doesn't just change knowledge. It changes identity. If this object was artificial, then the universe wasn't built just for stars and dust. And if it wasn't, then why did it look so wrong? Every side wanted answers, and every side wanted them now. But while humanity argued, something strange happened. Nothing changed. 3I/Atlas didn't react. The pulse didn't speed up. The light curve didn't shift. The thermal regulation stayed steady. It didn't respond to attention, didn't respond to belief, didn't respond to fear, as if none of it mattered. That was the most unsettling part. Because humans expect reaction. We speak, and we expect the world to answer. Even silence is a response. But this wasn't silence. This was indifference. The object continued its rhythm, unbothered by trending topics and breaking news, as if our awakening meant nothing to it. That raised a quiet, disturbing possibility. What if this wasn't about us at all? What if we weren't the audience? Leaks continued, some accurate, some wildly wrong. Diagrams were misread, graphs were dramatized. People found patterns where none existed, and ignored the ones that did. It became harder to tell signal from noise. Human static drowned everything, and still, the object stayed calm. No new behavior, no escalation. It didn't shine brighter to be seen, didn't dim to hide. It simply continued. That contrast was stark. Human emotion surged like a storm. The object drifted like a metronome, steady, patient, almost ancient. A few scientists noticed something ironic. The louder the world became, the quieter the object seemed by comparison. Not because it changed, but because we did. Our fear amplified everything. Our hope distorted timelines. Our denial bent facts. The data stayed the same. That forced an uncomfortable realization. Whatever this thing was, it wasn't interacting with us, which meant it wasn't here for us. And that hurt more than fear ever could, because being ignored is worse than being threatened. Some people clung to comfort. It's natural. It has to be. Others leaned into wonder. Maybe it's a relic. A probe. A message lost in time. Both sides shared one thing. They wanted meaning. But meaning doesn't always arrive when we do. The object had already lived its story long before we noticed. Our awakening was late. And that lateness mattered because it meant we weren't witnesses to a beginning. We were witnesses to a continuation, something already in motion, already decided, already unconcerned. As days passed, public interest spiked, then splintered. Some moved on to the next crisis. Others stayed obsessed, but the object didn't reward obsession. It offered no answers, no confirmation, no denial, just data, cold, precise, unchanged. One scientist put it simply, "We're shouting at the sky, and it's not listening." That sentence stayed with people because it captured the imbalance. Humanity was loud. The universe was quiet. And whatever drifted through it was quieter still, which led to the most haunting question yet. If this object doesn't react to our awareness, if it doesn't care that we've noticed, then what happens when something finally does? Because maybe this isn't the moment of contact. Maybe it's the moment of realization. The realization that the universe may be full of things that pass through, never noticing us at all. And as the noise settled into endless debate, one truth remained. The signal was never meant to wake us up. We woke ourselves up, and now we were left staring at something that refused to acknowledge we were awake. Which means the real mystery isn't why it ignores us. It's this. What kind of universe sends something like this? At first, the data felt scattered. A strange light curve here, a thermal shift there, a pulse that didn't belong. Each anomaly lived in its own file, its own chart, its own explanation. Easy to isolate, easy to dismiss. But time has a way of changing perspective. As weeks passed, as 3I/Atlas continued its silent journey, scientists stopped looking at moments. They started looking at history. They stacked the data, night after night, angle after angle, wavelength after wavelength, and something unexpected happened. The chaos faded, the noise softened, and beneath it all, a structure appeared. Not obvious, not loud, but consistent. Every anomaly, every strange behavior lined up. The light pulses, the reflectivity shifts, the thermal regulation. They weren't separate events. They were expressions of the same thing, a single repeating pattern. When plotted over long periods, the behavior formed cycles. Not perfect circles, not rigid loops, but rhythms. Like a melody that repeats, with slight variations. That realization hit slowly. And then all at once, because randomness doesn't do this. Chance doesn't remember where it's been. But this pattern did. It adjusted, but it didn't forget. The object behaved differently depending on where it was, but always within the same framework, as if it carried a rulebook, as if it had memory. Not memory like ours. No thoughts, no feelings, but recorded behavior. Conditional responses. If this, then that. If solar radiation increases, adjust reflectivity. If temperature rises, regulate heat. If stress drops, relax systems. That's not instinct, that's programming. The word sat heavy in the room because programming implies intention. Someone pulled up the earliest data, right after discovery, back when no one was paying close attention. The pattern was already there. Faint, subtle, but present. That meant the object wasn't reacting to observation. It wasn't learning from us. It arrived with this behavior built in. That mattered, because learning systems change. This didn't. It repeated, faithfully, over and over. The pattern wasn't about Earth. It wasn't about attention. It was about environment. Stars, radiation, distance. The object responded to space itself, like a recorder moving through conditions, logging everything, without commentary. That's when the question shifted. Not, is this artificial, but what is it for? Because design without purpose is rare, and this design was deliberate. Some suggested it was a probe, but probes usually transmit. They send data back. This didn't. It stayed silent. Others suggested a beacon, but beacons are loud. This was quiet, almost private. That led to a stranger idea. What if this wasn't meant to communicate, but to observe? Not us. Not planets, but physics. What if it was built to travel between stars, experiencing different environments, recording how matter and energy behave over time? A long-term experiment, set in motion ages ago. No destination, no deadline, just movement through the galaxy. That idea explained something unsettling. Why it didn't care about being noticed. Why it didn't change when we watched. Why it didn't respond. Because observers don't care who notices them. They care about consistency, accuracy, survival. The pattern supported that. The object conserved energy, protected itself, adjusted only when necessary, never wasted effort, never dramatized. It didn't behave like something waiting for contact. It behaved like something on a mission that didn't include us. One analyst pointed out something chilling. The pattern repeated even when no one was watching. There were gaps in observation, periods of downtime, clouds, equipment failures. When data resumed, the pattern picked up exactly where it should have been. As if the object never paused, as if it didn't need an audience. That suggested continuity, internal state, memory, and memory changes everything. Because memory means the object isn't just reacting, moment by moment. It's carrying context. It knows where it's been, in its own limited way. The pattern also showed no drift. Over time, random systems degrade, cycles stretch, timings slip. This didn't. The rhythm held. That implied durability. A system designed not to fail easily, designed to last. As more data accumulated, something else became clear. The pattern didn't optimize for speed or efficiency. It optimized for preservation. Every response minimized damage, minimized exposure, maximized lifespan, which raised a haunting possibility. What if this object wasn't meant to arrive anywhere? What if arrival wasn't the goal? What if wandering was the point? A record of the galaxy, written not in words, but in experience, passing stars, crossing radiation fields, surviving extremes, a memory device that moves. That idea unsettled people because it made the universe feel old, very old, and intentional in ways we're not used to. Some scientists tried to frame it in safer language, self-consistent structure, long-term stability pattern. But language couldn't soften the implication. Chance doesn't produce memory. Erosion doesn't repeat itself cleanly. Only systems do. The object's behavior suggested it had seen environments like ours before, not Earth, not humans, but stars like our sun. Heat like this, radiation like this. It knew what to do. That knowledge had to come from somewhere. Either experience or design based on experience. Both were unsettling, because either answer implies time, deep time, civilizations older than our history, or machines that outlast their makers. As the realization settled in, the mood shifted again. Less fear, less excitement, more humility, because this wasn't about us. It never had been. We weren't special. We were just another data point, another star, another passage. And that perspective is hard for humans. We like being the center of stories. This story didn't need us. The pattern continued as 3I/Atlas moved away from the sun. Thermal changes softened. Reflectivity stabilized. But the structure remained dormant, not gone, like a system entering low power, waiting. That raised the final question of the chapter. If this object carries memory, if it records environments across stars, who reads that memory? Does anyone? Was it built to be noticed? Or built to endure quietly until someone, somewhere, finally understands what it's carrying? Or worse, what if it was never meant to be read at all? What if its purpose isn't communication, but accumulation? a silent witness drifting through the galaxy, collecting truths about the universe, without ever explaining them. And if that's the case, then 3I/Atlas isn't a message, it's a mirror, showing us how small we are, how late we are, and how much of the universe has been moving long before we ever looked up. Because patterns don't care who finds them, they only care that they persist. And this one has been persisting for a very long time. It didn't stop suddenly. That would have been easier to understand. Instead, it faded. As 3I/Atlas passed perihelion, its closest point to the sun, something began to change. Not violently, not dramatically, quietly. The pulse that had held steady for so long began to weaken. The rise in brightness came a little slower, the fall a little softer, the rhythm less certain. At first, scientists thought it was interference. The sun is loud at close range. Radiation floods instruments. Noise increases. A weakening signal made sense. But then the data kept coming, and the weakening continued. The pulse didn't vanish. It thinned, like a voice lowering itself, as if choosing silence. That was strange, because near perihelion, everything should be louder. Heat peaks, stress peaks, outgassing peaks. Outgassing peaks. If the pulse was tied to survival, this was when it should have been strongest. Instead, it retreated. The light curve followed. Those strange bends and twists, the ones that had refused to behave, began to smooth out. Not perfectly, but noticeably. The curve started to look normal, like a rock again, like ice and dust obeying gravity, almost on cue. That timing unsettled everyone, because normalization didn't happen gradually. It happened in stages, as if something was shutting down, step by step. The reflectivity shifts slowed. Thermal regulation eased. The object no longer fought the sun as actively. It didn't need to. The worst had passed. Perihelion was behind it. The danger zone cleared. And with that, the behavior changed. Some scientists felt relief. Maybe it was stress behavior, they said. Extreme conditions cause strange effects. Callow, food. But others felt something colder, because this didn't look like stress ending. It looked like completion, like a process reaching its final phase. The pulse had always been steady, patient, almost disciplined. Now it wasn't failing. It was concluding. The signal thinned the same way a machine powers down, not collapsing, not breaking, just disengaging. That raised an uncomfortable idea. What if the pulse was never meant to last? What if it wasn't permanent behavior, but temporary operation, triggered by proximity, activated near a star, then shut off once conditions were logged? That would explain the timing. Why the strongest signals appeared during approach. Why regulation peaked near perihelion. Why everything quieted afterward. Like a system that wakes up, does its job, then sleeps. The data supported that. Energy use dropped. Surface changes stabilized. The object became inert, at least outwardly, which made it harder to study, harder to argue, harder to believe anything extraordinary was still happening. Public interest faded with the pulse. The internet moved on. Without constant mystery, attention drifted. That, too, felt unsettling, because it mirrored the object's behavior. Human curiosity spiked, then quieted. But scientists kept watching, because silence can mean many things. Failure is loud. Systems break with chaos. This silence was controlled, measured, intentional. The object wasn't losing function. It was conserving it. One researcher compared it to a deep-sea probe, active during descent, logging conditions, then dormant, drifting, waiting. Waiting for what? That question grew heavier as the days passed. The light curve now behaved almost exactly like a natural body. Rotation signatures appeared consistent. Brightness changes followed expectation. If someone discovered it now, with no history, they'd call it ordinary. That thought scared people, because it meant timing mattered. If we had looked later, we might have missed everything. All the anomalies, all the clues, all the questions, which raised a chilling possibility. What if the universe is full of objects like this, and we only ever catch them at the wrong time? What if most of them pass quietly, unnoticed, because their active phase is brief? The silence pressed in, and silence invites interpretation. Some argued the object had exhausted itself, that it was damaged, that regulation systems failed. But the data didn't show failure. It showed stability, a smooth transition, a graceful shutdown. Others argued it had finished its task, that perihelion was the goal, that the sun was the experiment, the stress test. And now that the test was complete, there was nothing left to do. That idea carried weight, because everything strange about 3I/Atlas centered around the sun. Heat, light, radiation. Stars are dangerous. Understanding them matters. If you were sending something across the galaxy, learning how stars affect matter would be valuable, especially if you plan to send more, or if you're deciding where to go. The object now drifted away from the sun, cooler, calmer. Its behavior barely registered as unusual. And that was the hardest part. The mystery didn't explode. It dissolved, leaving behind uncertainty instead of answers. One scientist put it bluntly, it's acting like it's done. Done with what? No one knew. Because whatever its purpose was, it didn't include explaining itself. The silence forced a shift in emotion. Fear faded, wonder softened. What remained was something deeper. Unease. Because unresolved mysteries don't end. They linger. They sit quietly in the mind, waiting to be remembered. As weeks turned into months, 3I/Atlas continued its outbound journey, still tracked, still measured, but no longer demanding attention. Just another object with a strange past. That's when the final question of this chapter settled in. Was the silence a failure? Did something break, or burn out, or shut down too early? Or was this always the plan? A brief awakening near a star, followed by long silence between suns? If so, then this wasn't the end of the story. It was the end of a chapter, and somewhere out there, long after we stop watching, the object will drift on, quiet, unchanged, carrying whatever it learned, past planets that never noticed, past stars that never asked. And maybe that's the most unsettling thought of all, that the most important phase, the phase where it does something, is already over. And we were lucky, or unlucky, to see even that much, because silence doesn't always mean absence. Sometimes it means completion, and sometimes the most dangerous moment isn't when something arrives. It's when it leaves, without ever telling us why. The story didn't end with an answer. It ended with paperwork. Graphs were finalized. Tables were cleaned. Language was softened. What had once felt electric, strange, unsettling, was slowly pressed flat. Official reports began to appear, carefully written, carefully reviewed, carefully empty. They spoke of measurement uncertainty, of instrumental limits, of unresolved but natural explanations. No lies, just omissions. The anomalies were still there, but now they lived in footnotes, small text, quiet sections, easy to skip. The pulse was described as low amplitude variability. The thermal steps became nonlinear heating effects. The reflectivity shifts were surface heterogeneity. Words that sound complete until you realize they explain nothing. This is how institutions survive mystery. They don't erase it, they bury it. Data wasn't destroyed. It was archived, stored in databases few people access, locked behind credentials and context, technically available, practically invisible. Because information doesn't need to be hidden to be forgotten. It just needs to be framed correctly. The public statements were calm, reassuring. There is no evidence of artificial origin. No cause for concern. Further research ongoing. There. That phrase, further research, did a lot of work. It promised answers without ever committing to them. Inside the scientific community, the mood shifted again. Not fear, not awe. Resignation, because everyone understood the rules. Extraordinary claims require extraordinary evidence. And this evidence, while unsettling, was subtle, distributed. Hard to point to in one clean sentence. It didn't shout. It whispered, and whispers don't survive committees. The archived truth wasn't a single revelation. It was a pattern, and patterns are fragile in bureaucratic language. They dissolve when separated. So they were separated. Light curve here, thermal data there, pulse timing somewhere else. Each anomaly alone, manageable. Together, uncomfortable. So, togetherness was avoided. No single report told the full story. No single paper asked the dangerous question. And without that question, there was no need for an answer. Some researchers were relieved. Careers stayed intact. Funding stayed stable. The world didn't panic. Order was preserved. But others felt something else. A quiet frustration. Because science isn't just about what we can explain, it's about what we choose to confront. And here, a choice had been made. Not officially, not consciously, but collectively. To move on. To treat the event as interesting, but closed. 3IATLAS faded from headlines. Then from conversations. Then from memory. New discoveries replaced it. New mysteries took its place. That's how progress works. Except progress usually builds forward. This felt like stepping sideways, around something. The archived data remained untouched, like a sealed room no one wanted to open first. Because opening it would force a question. Not about aliens, not about machines, but about authority. Who gets to decide when a mystery is worth unsettling the world? Is it scientists, governments, institutions, or is it chance? That decides which questions survive. The careful language did its job. Most people accepted it because uncertainty is tiring, mystery demands energy, and life moves fast. But a few couldn't let it go. They reread the reports, compared early drafts to final versions. They noticed what was missing, not data, tone, the early excitement, the unease, the wonder, all gone, replaced by restraint, professionalism, distance, which raised a haunting realization. Truth doesn't always disappear. Sometimes it's just deferred, postponed until someone braver or more reckless decides to revisit it. And that may take years, decades, generations. History is full of archived truths, ideas dismissed as noise, until someone notices the pattern again. Continents drifting, invisible waves, stones falling from the sky, at first all impossible, until they weren't. The difference here was scale. This wasn't a new force or a new particle. This was a question about intent, about design beyond Earth. And that question cuts deep, because if it's asked too early, it reshapes everything. Religion, philosophy, identity. So caution won, not because caution was wrong, but because caution was safer. As 3IATLAS drifted farther away, its file grew colder. Archived, indexed, referenced occasionally, never reopened fully. The object became a case study, not a catalyst. And that choice may define this moment more than the object itself, because one day someone will look back. They'll see the data, they'll see the patterns, and they'll ask, why didn't they push harder? Why didn't they ask the obvious question? And the answer won't be simple. It rarely is. Because humans don't fear the unknown alone. We fear what the unknown does to us. Our systems, our stories, our sense of place. Archiving truth is a way of buying time. Time to adjust, time to prepare, or time to forget. And that's the danger. Because the universe doesn't archive anything. It keeps moving, sending objects, repeating patterns, waiting, whether we're ready or not. The reports closed with familiar words. Further observation required. No definitive conclusions. A neat ending. A comfortable one, but comfort isn't the same as resolution. And deep down, many knew it. They felt it in the pauses between sentences, in the footnotes that ran too long, in the questions that were never asked aloud. The truth hadn't been disproven, it had been postponed. And postponement is a powerful thing. It lets generations inherit unanswered questions. It lets curiosity fade, until one day something else arrives, something louder, something impossible to archive. And then the question will return, not as a whisper, but as a demand. So the chapter closed quietly. Not with discovery, but with a decision. To store the mystery, to label it incomplete, and to trust that when the time is right, someone else will decide what the world is ready to know. But that leaves one final, uncomfortable thought hanging in the silence. If truth can be archived, who gets to unlock it? And what happens if the universe doesn't wait for permission? It didn't leave with drama. No final flare. No last signal. No goodbye written in light. 3I/Atlas simply kept going. Past Mars. Past the outer planets. Back toward the dark it came from. Quiet. Unchanged. Uninterested. From Earth, it shrank into a faint point, then into nothing at all. And just like that, it was gone. What remained were charts, cold graphs, archived numbers, lines that once caused sleepless nights. To most people, the sky looked the same as it always had, that something had shifted. Not in the universe, in us. Because once you've seen something that doesn't fit, you don't go back to the old story easily. Scientists kept working, of course. That's what they do. New objects, new missions, new puzzles. But 3I/Atlas lingered in conversations that happened late at night, not in journals, not in press releases, in quiet moments, in long pauses, in the space between sentences that never quite finished, because there was no ending, no confirmation, no denial, just an origin that remained unanswered. And unanswered questions are heavier than wrong answers. At first, many believed time would soften it, that distance would make it easier to forget. But distance has a strange effect. It doesn't erase, it clarifies. As the object moved farther away, one truth became impossible to ignore. Nothing about it had ever been for us. Not the pulse, not the thermal control, not the reflectivity shifts. Those weren't messages. They were behaviors, functions, things that made sense only if the object had its own reasons, its own history, its own purpose, independent of our curiosity. And that realization hurt more than fear, because it challenged something deeply human. The idea that discovery is about us, that the universe reveals itself to us. 3I/Atlas didn't reveal itself. We caught it mid-motion, like stumbling across a stranger on a road and realizing they were never headed your way. That reframed everything. If this object was artificial, then it wasn't built to be found. It wasn't meant to be understood. It was meant to endure, to pass through stars, to survive extremes, to exist quietly. Which raises a question no one likes to ask. What kind of civilization builds something like that? Not one chasing attention, not one seeking contact, but one that thinks in spans longer than memory, longer than culture, longer than species. A civilization that understands something we don't. That survival isn't about speed, it's about patience. And if that's true, then where does that leave us? We build probes to send pictures home, messages etched on metal plates, signals designed to announce who we are. Everything we send carries our voice. 3I/Atlas carried none. No identity, no explanation, just structure, just function, just persistence. It didn't say, "We are here." It said nothing at all. And maybe that silence is the message. Not a warning, not a greeting, but a mirror, showing us a different way of existing in the universe. One that doesn't need recognition, one that doesn't need answers right away. That idea unsettles us because we are young. We want meaning now. We want to know why things happen and what they mean for us. But the universe doesn't move at our pace. It doesn't explain itself. It doesn't check if we're ready. 3I/Atlas passed through our system like a reminder that not everything is part of our story. Some things are just passing through, and our role isn't always to understand. Sometimes it's only to notice. The charts remain. Anyone can look at them. Anyone can trace the light curve, the thermal steps, the fading pulse. And depending on who you are, you'll see different things. A strange rock, a rare anomaly, a statistical headache, or something else. something that quietly expands the boundaries of possibility. The unanswered origin forces a deeper question. Not, was this artificial? But, if it was, what does that say about us? It says we are not alone in complexity, not alone in building things that outlast us, but also not central, not chosen, not addressed. We are observers, late to the scene, and that may be the hardest truth to accept, because it means the universe doesn't revolve around intelligence. It tolerates it. It outlives it. It moves on regardless. 3I/Atlas will drift for millions of years, past stars that haven't formed yet, past systems that will never know it passed, carrying whatever purpose it was built for, whether that purpose is still relevant or long forgotten by its makers. That possibility lingers, that the builders are gone, that this object is older than memory, a relic of a question we don't even know how to ask. And if that's true, then understanding it may be impossible. Not because we aren't smart enough, but because we arrived too late, or too early, or simply at the wrong moment in its long journey. We like to believe the universe is waiting for us to figure it out. But maybe it isn't waiting. Maybe it's already told its story in ways we don't yet know how to read. 3I/Atlas didn't change the world overnight. There were no riots, no celebrations, just a subtle shift, a quiet recalibration of what feels possible. The sky didn't get louder, it got deeper. And now, when we look up, we know something we didn't before, that between the stars, there may be more than dust and silence. There may be artifacts of intentions older than Earth, machines without masters, messages without recipients, purposes without witnesses. And maybe the most honest answer to the mystery of 3I/Atlas is that there is no answer we're meant to have. Not yet. Or not ever. Because some things don't exist to be understood. They exist to endure, to move, to remind the universe that something once knew how to build and let go. So the object disappears into darkness. The data sleeps in archives, and humanity is left with a quiet, uncomfortable thought. If something artificial can cross stars, remain silent and pass us without caring, then the unknown isn't out there, waiting to be solved. It's all around us, moving, patient, indifferent. And the real question isn't whether we're alone, it's whether we were ever meant to understand the things that aren't.